Let's start this webinar called Writing Smarter Requirements that can be measured and tested. I am Almudena Diez, Senior Requirements Consultant in Visual Solutions. The agenda that we are going to see is this one that we are seeing here. The focus of the session will be in describing which are the properties that a good requirement should have in order to be smart and to be measurable and testable. Visure is a company specialized in requirements engineering, and it was founded in 2007. And what we do is we are the manufacturers and for sure distributors of Visure requirements, which is a requirement management tool. Given that we are the manufacturers, we are also experts in requirements engineering, because we need to know what you should do with requirements in order to build a product that is useful and powerful. We have our headquarters in Madrid, in Spain, but we have also offices in the UK, in the USA, and in Germany. And our consultants are IREP certified. They are certified as professional requirements engineers by the International Requirements Engineering Board, and we also give training to prepare for this certification. Okay. Okay. So let's now go into the subject of the webinar. So to write requirements, to specify requirements, we have different methods, like these ones appearing here. One is natural language, as we see here, but we have also another methods like structured language, for instance, UML diagrams or any other modeling language, pseudocode, or even formal specifications that is based on mathematical languages. So as we can see in this slide, we have here two axes. In this one we show the easiness of understanding, and we show preciseness in this other one. What happens here is if we have natural language, the position here is that natural language is very easy to understand. I mean, it's high, it's powerful in this sense, but its preciseness is very low. When if we see these other methods of specification, what we find is that we have structured language here, which is not so easy to understand. That is, you need some training or some at least some knowledge of what the notation means. And if we go to the other end of this graphic, we have formal specifications, which is very high in the sense of preciseness, but is quite difficult to understand. That is, you need a real training in order to be able to understand formal specification. So the situation we have is that natural language is the most common method for writing requirements. Why is this? Because in requirements engineering, the main focus or the most important point is understanding. The most important point is that it is necessary that everybody involved in the requirements process is able to understand the requirements. So most times the only common method, the only language that is understood by everybody is only natural language. So this is why requirements are written in natural language. It's not that I mean, there is no other advantage because, as you see here, the preciseness of requirements of natural language in order to write requirements is not very good. But as I said, communication is the most important thing. So we use natural language. Okay, what happens with natural language? With natural language, we come to situations like this one. We have these two guys here, which are more or less on the verge of of fighting each other with these hammers. One of them is saying, I distinctly said monorails, and the other said you did not. So this is a misunderstanding, and it's a situation that cannot be solved, or is not easily solved, because well, both of them are fully convinced that they are right, and probably they are, in the sense that probably this guy here said something about monorails, but well, at that moment this other guy was not listening, or whatever, or maybe he thought that he had said something about monorails, but he actually didn't. Anyway, the situation we have here is that this train is not going to work, and there is no way. I mean, obviously, this problem we have here has to be solved now, after all these rails have been built, which is not the very best of situations. So this is what happens when we use natural language. Okay, so what we are going to see now is what do we do to help us in using natural language in better ways. So we have said that most of the requirements are specified in using natural language. Well, everybody knows how to read and write. Yeah, domain experts, analysts, developers, users, everybody involved in a requirements process, in building systems, actually, all of them can read and write. So then, automatically, everybody assumes that people know how to write requirements. Is that true? Well, this is not so clear. A good requirement needs to have all these characteristics that appear here. Must be clear, concise, traceable, unambiguous, verifiable, necessary, design independent, viable, self-contained, and correct. Okay, so these 10 characteristics all of them are equally important, but in this seminar we're going to focus on the first 5 ones. If you remember, the title of the seminar is Writing Smarter Requirements, which are verifiable, right? Which are testable, which are measurable. So these first 5 characteristics that appear here help in the sense that we will be able to write better requirements which are measurable and verifiable. So this is why we're going to focus on these 5 characteristics. So we're going to see each one of them with more detail, and we're going to see some examples. A requirement must be clear. What we mean by that is that the requirement has to be easily understood. Okay, why is this important? Why is it relevant that requirements are clear? First of all, to improve communication. Again, the main problem we have is misunderstandings, so we are going to try to reduce the risk of misunderstandings. So if you write clear sentences, then it's not so easy that there are misunderstandings. So this is the main reason, but there is also another reason behind this idea of the requirements are clear, and is that if requirements are clear, this helps in retaining important ideas, in emphasizing the relevant information. Clear requirements are written mostly as short sentences, but the goal is not to save time. In general, it takes longer to write less. I mean, if you need to write a short sentence, you have to think before writing it. You have to really make sure that the important ideas are the ones that you are going to write, to put in the piece of paper. So in general, it takes longer to write less. Good. So now, how do we do that? I mean, we are using natural language, and okay, so how do we ensure, or what can we do using natural language and ensuring that what we are writing is understandable by everybody? Well, first, the first recommendation is you should write short and simple sentences. Also, there is another thing that is helpful in this way, is using a limited vocabulary. That is, you should create a glossary of terms defining the business or the domain terms, and use this vocabulary in a consistent way. That is, requirements should be written only using this vocabulary. Okay. So what we have in the end, if we follow these two recommendations here, what we have is a list of short sentences using a very limited vocabulary, using only the domain terms that we have defined in the glossary. So this is not good literature. This is actually, this could be even quite boring to read, but we are not writing novels. We are not doing literature here. What we are trying to do is using natural language as an engineering tool, which, well, is not necessarily the best one, but as we said, is the tool we have because it's the only one that is understandable by everybody. So even if from a literary point of view what we write is not very elegant or is not very attractive to read, but it helps to communicate with other people in a good way and avoiding these misunderstandings. So let's see a couple of examples here. Well, we have a requirement here, or let's say a candidate to a requirement that says, we believe that a good system should provide added value to the end user. Due to this, we consider that the system should perform adequately with a 2 GB disk, as it is the cheapest disk that the designated supplier can provide. Naturally, the user can decide to configure the system with a larger disk, which we also recommend, but we have attempted to solve all the problems posed by the use of the smallest disk, and we believe that they can be satisfactorily solved. Well, this is let's say a candidate to a requirement, but obviously it's not clearly specified. So we're going to analyze this with a little bit of more of with a little bit detail. First of all, something like this, just by looking at this long sentence, even if you don't read it, it is too long to be clear. I mean, something like 9 or 10 lines, as we have here. This means that this is very long and probably it's a bit rambling. So we don't like it just by taking a first look at it. But then we have also some other things like we believe, we consider, naturally, we also recommend, we have attempted, we believe again. All these things should not appear here. Subjectivity is forbidden in requirements specification. You should not give opinions. You should state facts. And there is something else. We have things like a good system should provide added value to the end user. Due to this, as it is, then the user can decide to configure the system with a larger disk, blah, blah, blah. To solve all the problems posed by the use of the smallest disk, they can be satisfactorily solved. All these things are not relevant. I mean, all this is information, but it's not clear. For instance, the first sentence, a good system should provide added value to the end user. Well, this is a blah, 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 which sounds very well, probably, but it's not saying anything. I mean, it's not adding information, relevant information to the requirement. So all these things should be avoided. You shouldn't use subordinate sentences, etc. So things like as it is, and things like that are not or should not be included in our requirement. So the only relevant information we have here is this information about the 2 GB disk and the cheapest disk that the supplier can provide. This is where the relevant information is. So probably after all these, what we would end up with having a requirement saying something about the size of the disk. Probably the requirement should be complemented by maybe a prototype or a study or a document explaining all these attempts we have made to solve the problems posed by using the smallest disk. And in the end, we have decided that they can be satisfactorily solved, or maybe not, whatever. But in the end, we need to end up with a measurable requirement, in the sense that the requirement should say the disk should have 2 gigabytes or 100 gigabytes or whatever, but something clear, concrete, that we are sure that really is really adequate for the system to perform correctly. And all the rest is not relevant and should not be here. Okay, let's go ahead with another property for requirements, and the next characteristics is conciseness. A requirement must be concise. What we mean by concise is, well, short sentences, something focused, and we also mean that a requirement should say one thing. A requirement should specify a necessity of a user or a characteristic of the system, but just one, not a set of them. Why is it important that a requirement is concise? First of all, again, to improve communication. If it is easier to understand a concise sentence, something that is clear. Okay, so I'm getting a message saying that the quality of the audio is not very good. If you have experienced some problems, please write some message in the chat or in the questions, and well, we'll try to solve the issue. Okay, so we said that to improve communication is the first reason. Okay, the second one is to pay attention to each requirement. That is, if you write a set of concise sentences, if you write a set of characteristics individually emphasized, then it's easier than when somebody reads the requirement specification, when somebody's reading all the list of requirements, is paying attention to each one of the characteristics. Instead of, if they are part of a long sentence with many things, then maybe probably it's easier that something is not, or some part of the sentence that you are reading is not really understood, or you don't really pay the attention you should. And there is another important reason, which is to allow traceability. We will talk a bit about traceability in a minute, but if you try to trace something that is not concise enough, probably you are tracing a requirement to a very large set of elements, and then traceability stops being relevant. Okay, so how do we ensure that our requirements have this characteristic? Well, there are some recommendations we should follow. One is watching the use of connectors such as and, or. It doesn't mean that they are forbidden. That is, a requirement could be perfectly good, even if it contains and, but you should just take a look at it. Same thing if in the requirement there is a list, numbered or bulleted, or if there are tables. These requirements, if a requirement includes some of these or one of these things, it is not automatically a bad requirement, but it is suspect. So you should check, you should think again. Let's see some examples. The first one is quite obvious. We have this sentence saying sales personnel must be able to manage their client lists and generate reports. This is not concise enough. We have this and here, and actually here we have two high-level functional requirements. First one is sales personnel must be able to manage their client list. Sales personnel must be able to generate reports. These are two functions which are different and which should be stated separately. Let's see another maybe not so obvious example. The system will run on Windows and Unix. Well, this could be, it looks more or less okay, right? So how do you decide if the requirement is concise or not? Let's go back and think of the goals. We said that the reason behind conciseness, there are three reasons. So we said that one is to improve communication. Well, the system will run on Windows and Unix is clear enough. Everybody understands it. Okay. The second reason was to pay attention to each characteristic. Well, there are only two things here to operating systems, Windows, Unix. It doesn't look like very really indispensable to split the requirement in two parts. But what happens with traceability? Are you sure, for instance, that you are going to build a system running on Windows and Unix in the first version? What happens if you decide that the Windows version will be the first one? Maybe the first version of your system will run only on Windows, and then the second one, or maybe version 3 in 6 months, will run also on Unix. When you try to trace the requirement to a version of the project, of the system, you cannot. I mean, you have to explain. No, well, the first part of the requirement will be covered in version 1, and the other one will be covered in version 2.5. So this is not good. So if you have the impression, or if you think that maybe you will not be able to trace your requirement to a unique version of the product, then you have to split it for sure. Or, for instance, if you are going to have a set of separate or of different tests to cover these two different characteristics, then it also should be split. Otherwise, traceability will not be meaningful. So pay attention to traceability when you need to decide if a requirement is concise enough or not. Let's talk a bit about traceability now. Why is important? Why is traceability so important in requirements specifications? In order to perform change impact analysis. If a requirement is going to change, or any element in the life cycle has to be modified for some reason, then what you should do is to be able to perform a change impact analysis to say, okay, which are the items that are going to be impacted. This is the main reason. Another one is to be able to solve inconsistencies between requirements. That is, if a requirement if, for instance, two requirements are contradict each other and cannot be achieved at the same time with the system, then you need to know where this requirement come from, or who was the source of the requirement of both of them, in order to be able to talk to these people and to decide which of these conflicting requirements is going to go ahead in the implemented system. So this is another reason. But the main one is change impact analysis. If there is no traceability, then the change impact analysis will mainly consist on making assumptions. It's not analysis anymore. It's, well, I'm going to try and see if I'm lucky and I do not make a mistake and I miss something that all should be also modified. How do we ensure traceability? Writing concise requirements, as we said before, and also identifying requirements with a code that is unique in the project. So then it is possible to say requirement 1 is traced to tests 1, 3, and 4, or whatever. Okay, the next characteristic is ambiguous. This is the main problem with natural language. Natural language is ambiguous. It's in its own nature, and it's very difficult to avoid ambiguity. Why is important to avoid ambiguity? To improve communication. This is the reason here. The problem is with natural language is that it is ambiguous, so it is very easy that there are misunderstandings. Well, the reason is very clear. It's not so simple to avoid ambiguity. How do we ensure the requirements are unambiguous? Well, first, we should avoid imprecise terms, things such as fast, easy, updated, reliable, among others, etc. This etc. here has two meanings, or it is here because of two reasons. First one is that there are many imprecise terms in natural language. There are many words that are ambiguous, that are imprecise. So this etc. means all of them that are not here, but are also ambiguous. But also the etc. itself should be avoided when writing requirements. Things like among others, etc. It's better to have a list, a bulleted list, even if maybe the requirement is not concise. But it's much preferred to have a list of items, of characteristics inside a requirement. But at least this list of items has bounds, right? I mean, it starts and finishes. But if you have an etc., nobody knows where it finishes, and this is not good. So you should avoid these kind of things, and also avoiding synonyms and homonyms. Remember the glossary of terms. You should build the glossary of terms and avoid synonyms, because they add ambiguity. If you use different words, maybe somebody reading the requirement could think, I mean, I'm not really sure if this is the same thing or it's a different one. So it's better to stick to the glossary of terms. And there is a third recommendation, which is formally reviewing the requirement document. Why? Because a natural language is ambiguous, and it cannot be avoided fully. For sure, avoiding imprecise terms helps, but in the end, you need to, or it's very useful that somebody who also knows about the domain, but is not directly involved in the process of writing the requirements, should read the requirements, because the person writing the requirements thinks that it is very clear, that everybody is fully clear and understandable. But when somebody else reads it, probably it's very, very likely that he identifies things that, or ambiguities, or things that are not as clear as they seemed, right? So it's very recommended, it's pretty, to formally review the specifications. So let's see some examples. Well, examples of ambiguity, there are thousands. We have this one here. What does user-friendly mean? Well, user-friendly is a term that fortunately has gone out of fashion now, but in the 90s it was I mean, all requirement specifications at some point they said that the interface would be user-friendly. What does it mean? You have to explain, or you have to make it more concrete. For instance, saying that the user interface will be built according to this standard, or will be built following this set of rules, which are the ones used in this organization, something like that. Or maybe defining a set of characteristics such as this one. The system will provide a user interface where all functions will be available through menus with a maximum depth of 3 levels, for instance. Something, I mean, a set of characteristics that really help in defining what is the meaning of this user-friendly thing. No? Well, as I said, there are many examples of ambiguity. We have here a requirement, well, a candidate to a requirement, which says the application must be very stable. Even when many users are connected simultaneously, speed will not be affected. Okay, what does the person who wrote this requirement mean by stable many users speed? Well, actually here we have not one requirement but a set of requirements. I mean, this requirement is not only ambiguous, it's also not concise, so we have to split it. And we will need characteristics such as these ones. For instance, mean time between failures will be greater than once a week, or whatever. What we mean by stability, right? Many users will allow 10,000 users or 1,000 users, or whatever. And speed, what do you mean by speed? Maximum response time will be 1 second in this situation. If we look at it even more carefully, we could wonder about simultaneous. what do you mean when you say here that many users are connected simultaneously? I mean, simultaneously doing what? So maybe the second requirement could be improved, saying something like this. The system will allow 1,000 users to operate, all of them making simultaneous requests to the database. So this is more precise. So, excuse me. Sorry. So, be very careful with ambiguity, because it's very, very easy to write ambiguous requirements and very difficult to eliminate all ambiguity from our specifications. This is another example. The colors of the user interface must be better than in the previous version. This is a requirement that was written in the specification, in a real specification. Actually, a colleague of us sent this example. And well, you read this, and when you are the responsible for the user interface, imagine the situation where you find something like that. Maybe to solve this ambiguity, because for the user it's very clear. I mean, he's using a system with a user interface he doesn't like at all. He thinks that it's very ugly. Well, this is good, but what do we do to solve this problem? Obviously, this is totally subjective. I mean, it depends on who is looking at this user interface. He will think that the colors are beautiful or not, or whatever. So maybe in this case, you need to build a prototype of the user interface using different colors, and then eventually the user should say, okay, this version I like. So maybe eventually you have a requirement saying the colors are the ones, the colors of the user interface will be the ones in the prototype, and then you have the prototype as information associated to the requirement. But somehow, anyway, this could be this requirement could appear in the first version of the specification, right? I mean, the user says this, and that's it. You write down this information. But then, eventually, in the agreed version, in the accepted version of the requirements, you should have something more substantial in order to be able to develop this user interface. Okay, and the last characteristic we're going to see is verifiability. We mean by that requirements should be testable. That is, that there should be some method to decide if the system meets the requirement or not. Why is it important? Again, to improve communication. If there is a method to say, okay, the requirement is met by the system, then it is much more unlikely that there are misunderstandings. And also to agree on objective conditions to determine if the delivered system is correct or not. Otherwise, you could end up by having long discussions with between user and supplier, trying to decide if you are going to pay or you are not going to pay for this system because you agree or you don't agree on if the system meets the requirements or not. How do we ensure that requirements are verifiable? Well, asking yourself how the requirement will be validated. Which are the conditions for success? And also including quantifiable criteria. The typical example of that is the non-functional requirements that we were seeing before, talking about speed, for instance, or things like that. You should write some numbers, as we did with the number of users or the performance. The system should respond in 1 second. So for non-functional requirements, most times you need quantifiable criteria. Okay, so we have examples such as this one. We have a requirement here saying the belt must operate continuously for 5,000 hours at 7 kilometers per hour without malfunctioning. This requirement is not ambiguous, it is very clear, but how are you going to test it? Well, you could hire a set of people, a really large group of people, and then the belt will start, and the first one in the row of these people will start running until he gets exhausted, and then he goes, and another person comes and again runs for a few minutes until he gets exhausted, etc. 5,000 hours is like I don't know, by like 200 days, something like that. So obviously this is not a good way to test it. So you need another way to test this requirement. So in cases like this, what you should do is to define an acceptance criteria, something like, let's say, a statistical test. Instead of having one belt operating 5,000 hours, what you have is maybe 5,000 belts operating for 1 hour, or something like 100 belts if they operate continuously for, let's say, 5 hours without malfunctioning. Then, okay, we accept that the requirement is met. So these kind of statistical conditions can be defined in order to test requirements when the method for testing is not obvious, or is not simple, or it's very expensive, or is difficult for some reason. We have, let's go back to our old friend, the user-friendly interface. We said before that we could solve this problem we have with this requirement by, writing other things, or a set of other requirements, defining more precisely user-friendly interface. But we could also write an acceptance criterion, something like that. 9 of 10 users will be able to add a new customer, modify an existing one, or delete it in a maximum time of 30 minutes without any help from outside. So this is an acceptance criterion that could be defined and associated to the requirement. So if we are able to fulfill this acceptance criterion, then the user will accept that the requirement is fulfilled. So this is another way to solve ambiguities. In this case, this example is we have an ambiguous requirement, so we are not able to say how we are going to test it. So we need to define further the requirement, to add something, which is this fit criteria or acceptance criteria. Good. So let's see now quickly which are the criteria for validating a set of requirements. Each requirement should have all these characteristics that we have explained here. Now we have also to validate or to decide if the set of requirements is good, is okay, if it's really is useful, is enough to be able to go on with the life cycle and to build the system. So the set of requirements has to be complete, consistent, modifiable, and prioritized. What we mean by complete is that all requirements are there. I mean, there are no missing requirements. There are no requirements that keep later, that appear at the worst possible time in the life cycle. In order to be able to say, or to make sure that the requirement specification is complete, that we have everything there, we recommend first using checklists. Things like the list of stakeholders that should participate in the project. I mean, everybody who could have requirements should participate in the requirements process. Otherwise, the requirements coming from this role, from this person, should not be taken into account. Also, to have a checklist of the types of non-functional requirements that usually appear when building systems of a specific type. It's also useful in order to not forget that they should be there. There is also another thing that is useful, which is to review the requirement specification with domain experts. Why? For instance, domain experts could know that, could be aware that legislation applies in this type of systems. So if nobody participating in the requirement process is aware, then the system will not comply with this law, and it will not be useful. I mean, it will not be possible to put it in production. So it's this kind of things should be also taken into account, and many times there is nobody in the, let's say, the technical team who knows these things, but domain experts should know about it. The next thing is consistency. The requirement specification must be consistent. That is, there cannot be contradictory requirements. We recommend, in order to make sure that all requirements can be met, reviewing the requirements grouped according to different points of view. For instance, if you group together all requirements having to do with performance, maybe you find out that there are two conflicting requirements coming from different users, and that cannot be met at the same time. Also, it's important, in order to ensure consistency, to identify the origin of each requirement. As we said before, you need to know where this requirement comes from in order to be able to discuss with users or to trace the requirement back to the origin, and then to decide which of the two conflicting requirements is going to be implemented and which one is going to be discarded. Next characteristics is modifiability. I mean, the requirement specification is going to change in time. This is something that is going to happen. We have to live with it. So we have to prepare somehow our requirement specification in order to be able to generate new versions, etc. So what we recommend is to keep track of versions, to create baselines that serve as a starting point for modifications, and of course to trace requirements, as I said before. Otherwise, when we try to modify the requirement specification, we will not be able to perform a change impact analysis. We will make assumptions. And the last characteristic is that requirements have to be prioritized. I mean, requirements should be ranked by priority. We should know how important is one requirement compared to the others. So what we recommend here is to establish a rule to define the priorities in the project. For instance, like priorities should be high, medium, low, or something like that, and then working with the users in order to make sure that we know how important the requirements are to them. Okay, now let's see very quickly how a tool can help us in checking if the requirements are good or not. Let me show you a tool that's called Visual Requirements Quality Analyzer. Actually, we have a requirements management tool which is called Visual Requirements, and Quality Analyzer is a tool developed by our colleagues in another company called the Reuse Company, and we have integrated together with them. We have developed an integration. So you how it works is you write your requirements in Visual Requirements, and then this tool, Quality Analyzer, can help in identifying which are the rules that are not met by the requirements that you have written. So let's see a couple of examples. Let me see. Okay. So we have a list of requirements here, and for instance, well, the most useful way to work with a tool like this is you first write your requirements. You write a set of requirements, and then, for instance, during the night, you apply this quality analyzer, and then in the morning, the analyst could check what's the result of this analysis, and you just have a column here saying the quality of the requirements, right? So the values could be medium, low, or high. So we have a set of our set of requirements here, and we see the quality. So let's see in more detail what's the information that this tool provides us. So if we click here on View Quality, we have selected here requirement func 200. Okay, and we have here, it says that the requirement is this one. It says the user will be able to connect and disconnect new appliances to the CCC system. So let's see what what the tool tells us. If we select here, for instance, acronyms, we see that we have this CCC here that is recognized as an acronym, and it is not defined in our glossary. I mean, it is possible in this tool to define a glossary of terms. It comes with a predefined set of, for instance, ambiguous terms or things like that, but it can be improved by adding new terms. But if these terms like this are not found in this dictionary, then the tool tells that you are using an acronym that is not defined. We have, for instance, connectors, such as AND here. So we have an AND here, so the tool says, okay, this is suspect, please review. But we have also more information like domain verbs, and it says here that you have two domain verbs, connect, disconnect. This is also an indication that maybe the requirement is not concise enough. I mean, the and is one thing, but you have also these two verbs that probably mean that you have two different characteristics here that are mixed up in the same requirement, and it's very likely that you should split it. Okay, so this is the kind of information we might have here. Let's see another example. Let me see. We have here, for instance, a usability requirement called system interface. Okay, so the requirement says the CCC system must be simple and include an easy-to-learn human-machine interface. Okay, so if we review the metrics here, we see that it tells, for instance, that you should avoid using acronyms which are not declared into the ontology. This is what I explained before. Ambiguous sentences must be avoided, right? Well, there are also some other things like the requirement is volatile. It means that the number of versions of the requirement is higher than a threshold that you can define. Well, so we have some this metrics information telling us which are the metrics that are not good, that have for which the quality is either low or medium. If we go again to the textual metrics, we can see more detailed information, and we have again the CCC acronym, and we have now the ambiguous sentences. So the tool tells us that simple, that easy are ambiguous terms and should not be here. We have also connectors. We have the AND here. So yeah, a tool like this can help us in identifying which are the requirements that are, in principle, candidates, let's say, to be reviewed. The tool does not rewrite the requirement. Okay, we should rewrite the requirement. Actually, using this tool, it's possible to rewrite the requirement here and then recalculate the quality, and then see if now it's okay or not, if it is according to the rules. But well, in any case, it can be a very useful tool in at least generating this calculation of the quality, meaning that you have, for instance, you could identify quickly which are the low quality requirements. So we have this requirement here, which is the one that has low quality. It means that it violates a lot of rules, more than the rest, like all these long lists here. In any case, this tool could be helpful for analysts in this sense. I mean, I write my requirements and then the tool tells me, please check again this requirement. But also, well, all these rules that we have seen here are they can be defined and they can be configured by the quality or the methodology responsible. So then you can decide, for instance, which are the rules which are more important, or which are, for instance, you may decide that you want people to write an ambiguous requirement. So the focus of the emphasis is going to be put on ambiguity. So then what you do is you build this dictionary of ambiguous terms, using as a starting point the default one that goes with the tool, but then you can improve it, adding more things. And then you could state a rule saying that if there is only one ambiguous term, in a requirement, then this requirement will be tagged as low quality. So then people will be, analysts will see every time they write an ambiguous term, this requirement will be enhanced as being a bad one. So then it is, in this sense, it is a tool also to help in the training of analysts to write good requirements. And it can be reconfigured anytime you like, so maybe after a while people already write unambiguous requirements, so then you put the focus in something else, like in conciseness. So there are also rules here checking the number of characters or the number of paragraphs in a requirement and things like that. So this can be a very useful tool in helping us to learn how to write good requirements, and for the it's also possible to extract from here reports or metrics. So you could have information as the quality manager. You could have information on which are the rules that are violated most often, for instance. So then you could decide, okay, my analysts need training in this special aspect, because, well, it seems that all of them or most of them fail in that part. So yeah, tools can be useful, tools like this, but I would like to also tell you that it's automation, not automagic. That is, the tool, as I said, tells you this is bad, this is not a good requirement, but the analyst has to rewrite the requirement. So, I mean, it's a tool that is helpful, but don't put your expectations too high. And also remember that a fool with a tool remains a fool. That is, if you do not know how you should write good requirements, then no tool is going to do the work instead of you, and you are not going to get a good requirement specification. Okay, so this is what I wanted to tell you. I see there are no questions here. If you have any question, please write it in the questions section. So I will be happy to answer them.